The first type of problems you're going to need to solve is if you're giving a right triangle and two of its sides to come up with the trig functions for both acute angles in the right triangle. So remember, our trig functions are ratios of various sides to each other. So the first step is to come up with the third side, and you're going to use the Pythagorean theorem. So the third side of the triangle is the square root of hypotenuse squared minus the other leg squared, which is the square root of 169 minus 25, square root of 144, square root of 144 is 12. Hopefully some of you recognize this as a 5, 12, 13 triangle from geometry class. Pythagorean triple. So the first thing I want to do is I want to label my two acute angles. I'm going to label one of them theta and the other one beta. First, what I'm going to do is with respect to theta, so I'm going to label my sides. Opposite side of the right angle is the hypotenuse. The other one that touches theta is the adjacent, and the remaining side is opposite. From there, I'm going to use my trig definitions. The sine of an angle is opposite over hypotenuse. The cosine of an angle is adjacent over hypotenuse, 12/13. The tangent of an angle is opposite over adjacent, 5/12. Then the remaining three trig functions, the cosecant of an angle is the reciprocal of sine, so 13/5. The secant of an angle is the reciprocal of cosine, 13/12. And the cotangent of an angle is the reciprocal of tangent, which is 12/5. Now I'm going to come up with the 6 ratios for beta. So I'm going to relabel my triangle. Side opposite the right angle is the hypotenuse. The other side that touches beta is adjacent. And the other remaining side is the opposite. The sine of beta is equal to opposite over hypotenuse, 12/13. The cosine of beta is adjacent over hypotenuse, 5/13. The tangent of beta is opposite over adjacent, 12/5. The cosecant of beta is equal to the reciprocal of the sine, which would be 13/12. The secant of beta is the reciprocal of cosine, which would be 13/5. And the cotangent of beta is the reciprocal of tangent, which would be 5/12. Please note that all of the numbers that I have for theta and beta are the same. They are just for different trig functions. So let's just kind of look at this. What is the relationship between theta and beta? Well, I know that beta is equal to 90 degrees minus theta. So beta is 90 degrees minus theta because both of these have to add up to 90 degrees. And let's look at the relationship here. Well, they add up to 90 degrees, and another name for two angles that add up to 90 degrees are complementary angles. And what we're going to do is we're going to come up with what are called our cofunction identities. Notice the word co is in cofunction. It's in complementary. And then I have a cosine, a cosecant, and a cotangent. And all of these relate together. what it says is the sine of an angle is equal to the cosine of its complement. The tangent of an angle is equal to the cotangent of its complement. And the secant of an angle is equal to the cosecant of its complement. I'm going to write those out. The sine of an angle is equal to the cosine of its complement. Similarly, the cosine of an angle is equal to the sine of its complement. The tangent of an angle is equal to the cotangent of its complement. The cotangent of an angle is equal to the tangent of its complement. The secant of an angle is equal to the cosecant of its complement. And the cosecant of an angle is equal to the secant of its complement. Cofunction identities are the next 6 identities that you will need to memorize or be able to use. They will be on your identities test when we get done with all of the identities. So let's check this. The sine of an angle is equal to the cosine of its complement, 5/13. The cosine of an angle is the sine of its complement, 12/13. The tangent of an angle is equal to the cotangent of its complement, 5/12. The cosecant of an angle is equal to the secant of its complement, 13/5. The secant of an angle is equal to the cosecant of its complement, 13/12. And the cotangent of an angle is equal to the tangent of its complement, 12/5. So if you know the ratios for one of your acute angles, you don't actually have to label the other side. You can just use your cofunction identities to come up with the trig functions for the other angle. You can do it either way, but you are still required to know those cofunction identities. So I'm going to do one more triangle. And this time I'm going to use the cofunction identities to come up with my beta angles. So I'll rewrite theta and beta. So theta, beta. I'm going to call this side 5 and this side 2. So I need to come up with the third side. The third side would be 25 minus 4, which is 21, underneath the square root symbol. So I now need to label my triangle. I'm going to label it with respect to theta. So I have hypotenuse, adjacent, opposite. So sine is opposite over hypotenuse, 2/5. Cosine is adjacent over hypotenuse, square root of 21 over 5. Tangent is opposite over adjacent, 2 over root 21. However, I don't want to leave radicals in the denominator, so I'm going to rationalize it by multiplying the numerator and the denominator by that radical. So I end up with 2 root 21 over 21. The cosecant is hypotenuse over opposite, or this one flipped over, so 5/2. The cosine is, the secant is 1 over cosine, so it's 5 over root 21. Again, I need to rationalize it. So I end up with 5 root 21 over 21. And then the cotangent is the tangent rationalized. So square root of 21, reciprocal, square root of 21 over 2. So now if I want to find out beta. So I know the sine of beta is the cosine of its complement. So square root of 21 over 5. The cosine of beta is the sine of its complement, 2/5. The tangent of beta is the cotangent of its complement, square root of 21 over 2. The cosecant of beta is the secant of its complement, 5 root 21 over 21. The secant of beta is the cosecant of its complement, 5 halves. The cotangent of beta is the tangent of its complement, 2 root 21 over 21. So there are two examples of, you've given two sides coming up with the trig functions for both acute angles. Next thing I'm going to do is I'm going to give you one side and an angle measurement, and we're going to come up with the trig functions of the other angles. So the next thing is if I give you an angle and a side length to come up with the other angles and the other side lengths of a right triangle. So the first thing I want to do is I want to label the sides and angles that they give me. And they tell me C is 5. And if I give you one of the angles in a right triangle, one of the acute angles, you should be able to come up with the other one by 90 minus 45 is 45. So what we're going to do is we're going to take the angle they gave me and we're going to label the sides. Hypotenuse, adjacent, wrong, opposite, and adjacent. Then what I want to do is I want to look at what they gave me, which are C, which is the hypotenuse, and what I want to find. I want to find A. Well, A is the opposite. So which trig function has opposite and hypotenuse in it? That would be sine. So I know that the sine of 45 degrees is A over 5. So I know that the sine of 45 degrees is equal to A over 5. Multiply both sides by 5, and you get A is equal to 5 times the sine of 45 degrees. And for right now, your problems will tell you whether they want exact answers or the decimal points. We're going to go to one decimal point here. Make sure you're in degree mode, so 5 sine 45, and I get 3.5 for its length. This is a rounded number. A lot of you would think to use the Pythagorean theorem to come up with the last number. But because that is a rounded number, you don't want to use it in its calculations. So I'm going to do the same thing. I was given C, I want to know B. What trig function has adjacent and hypotenuse in it? That would be cosine. So I know the cosine of 45 degrees is B over 5. Multiply both sides by 5. Forgot the 5. Stick it in your calculator, and again you get approximately 3.5. So let me use the rounded number with the Pythagorean theorem to see what I'd get. I'd get square root of that squared minus that squared. So square root of 5 squared minus 3.5 squared. And I get 3.57, which you would have rounded to 3.6, and you would have got the wrong answer on a quiz or a test. Let's do another one. 32 degrees is my A. 90 minus 32 is 58. So I now have that angle. They tell me that B is 10. I'm going to take the angle they gave me, label my side, hypotenuse, opposite. I want to find A. They gave me B. The trig function that has opposite and adjacent in it is tangent. So I know that the tangent of my angle is opposite over adjacent, which would be A over 10. Multiply both sides by 10, and I get A is equal to 10 tangent 32 degrees. Calculator, 10 tangent 32, and I get 6.2. I do the same thing with C. I have a hypotenuse. I was given the adjacent. The trig function that has adjacent and hypotenuse is cosine. So I know that the cosine of 32 degrees is adjacent 10 over the hypotenuse, which is C. Think of this as a proportion. I'm going to swap the extremes of my proportion and rewrite it as C is equal to 10 over the cosine of 32 degrees. So using my calculator, 10 over the cosine of 32, and I get 11.8. So if you're given one acute angle and one side, this is how you come up with the remaining angles and remaining sides for a triangle. Next, we're going to come up with some special right triangles that you should memorize the side lengths of. There are two special right triangles that you should have memorized from geometry class. The first one is a 45-45-90, and the second one is a 30-60-90. From geometry class, we learned that the side lengths are 1, 1, square root of 2. And for 30-60-90, the short side is 1, hypotenuse is 2, long side is 3. Short side is 1, hypotenuse is 2, long side is square root of 3. You should immediately be able to come up with the sine, cosine, tangent of 30 degree, 45 degree, and 60 degree angles. So the sine is opposite over hypotenuse, 1 over square root of 2. Rationalize it, and you get square root of 2 over 2. Cosine is adjacent over hypotenuse, 1 over root 2. Rationalized is square root of 2 over 2. Tangent is opposite over adjacent. It's 1. For 30 degrees, opposite over hypotenuse, 1/2. Cosine of 30 degrees, adjacent over hypotenuse, square root of 3 over 2. And the tangent of 30 degrees is opposite over adjacent, 1 over root 3. Rationalize, and I get the square root of 3 over 3. For 60 degrees, the sine of 60 degrees, opposite over hypotenuse, square root of 3 over 2. Cosine of 60 degrees, adjacent over hypotenuse, 1/2. And the tangent of 60 degrees, opposite over adjacent, which is the square root of 3. So one thing I want you to note, let's go 30, 60, then 90. Well, let me write a relationship up here. You should note that the square root of 1 over 2 is less than the square root of 2 over 2, which is less than the square root of 3 over 2. Well, the square root of 1 is 1/2. So these are in numerical order. Square root of 1 over 2, square root of 2 over 2, square root of 3 over 2. So 1/2, square root of 2 over 2, square root of 3 over 2. So if we know these three numbers, this is the sine of 30, 60, then 90. 30, 45, and 60, sorry. And it is the cosine, so cosine of 60, 45, and then 30. So this may help you come up with remembering what these are. And for tangent, square root of 3 is more than 1. So square root of 3 is the big one. 1 is the medium one. And the square root of 3 over 3 is the middle one. So this would be the tangent of the 30, 45, and 60. So if you remember, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2. Square root of 3 over 3, 1, square root of 3, and you know these relationships that may help you come up with some of these numbers. So these are expected to be memorized. Later on in this chapter, you'll be expected to come up with these on the spot. You do not want to have to take a significant amount of time to come up with them. They should become automatic for you. So it's going to take practice. So that is the end of section 9.1. You will have 2 separate days worth of homework for this section. You're going to have a sheet when you come into class. And that sheet when you come into class is going to be the same problems as guided practices 1, 4, 7, and 9 that you're going to do when you come into class after watching this video. 1, 4, 7, and 9. And that's going to be my check to see whether you internalize this information. So you know what you're going to be doing when you come into class, right at the beginning of class. And then after you do this worksheet, you're actually going to get the homework for the first section of section 9.1.